Okay. It's loading. Okay. Hello, everyone. I am Juliet, and Duan, Kevin, Sarah, Yajin, and Sung Chan, including me, will going to talk about biodegradable plastic. So we will going to conduct our presentation in this order. Yes. Oh, okay. So, what is biodegradable plastic? The name gives the hint what does this actually mean. So, the biodegradable plastic is a plastic that can be broken up by the microorganisms and it is generally made from plants. And there are over 20 types of biodegradable plastics and we want to introduce 5 of them. So, first, polylactic acid is the second most produced plastic in 2020, but I make the mistake, so please appreciate for that. And it is mostly made from corn, also sugar cane, tapioca root, cassava, and sugar beet pulp. And polyhydroxy acid is made of canola oil, and it is able to change its properties so it's flexible. And it is also used in medical application, but for these details, we are going to explain later. And polybutylene succinate has high heat resistance. So unlikely with other common plastics, we cannot actually contain the high heat things in the plastic, but this can be able. And moreover, starch blends found abundantly in corn, wheat, rice, potato, tapioca, pea, and many other botanical resources. And we can see this starch commonly, which 75% of all organic material on Earth contains it. And lastly, polybutylene adipate terephthalate can biodegrade within about 6 weeks, which is 1 month and a half.
So in mechanism, there are 4 phases in plastic biodegradation. First is deterioration, second is biofragmentation, third is assimilation, and fourth is mineralization. So first, in this process, the plastic polymer breaks down into polymer fragments by photodegradation, mechanical degradation, and oxidation. You can just think as a big plastic splitting into small ones by these natural factors. And second is biofragmentation. So in order for microbes to observe the collapsed polymers, it needs to be cleaved into small molecules, which is like molecules with lower molecular weights. And the catalytic enzymes or radical, which is a molecule that has an unpaired valence electron, secreted by microbes, leads this process. And assimilation. Then the fragmented plastics inside the microbe's cytoplasm goes through the process of metabolism. Then the microbes use the molecular substance for their energy production or cell growth. And as the result of assimilation, there are some emission products coming out such as oxygen, carbon dioxide, nitrogen, methane gas, and water. And this process is known as mineralization, and biodegradable plastic goes back to the nature like this.
Now we are going to talk about the pros and cons of biodegradable plastics. First, the PLA, polylactic acid, was made of fermented and defined glucose extracted from natural plants. In other words, it is not derived from fossil fuel-based chemicals. Also, the biodegradation period is much shorter than that of regular plastics. PLA is harmless to the human body, while there are a lot of concerns about the toxic fumes the conventional plastics are releasing. PLA does not have those concerns if they are managed properly. The unit price is relatively cheaper than other biodegradable raw materials. Next, PHA, polyhydroxyalkanoate is composed of materials that are obtained from nature, which means it is eco-friendly. Also, PHA is thermoplastic. It can be melted and reformed multiple times at melting temperature. Human friendliness is also the advantage of PHA. This is directly related to biocompatibility, which is going to be explained later on. The price of PHA is a mere 2. The price of PHA is almost same with the price of regular plastics. Finally, PBAT, polybutylene glyphosate terephthalate, has the excellent tensile and tear strength. Next, it is highly durable and processable, so it can be used in packaging or biomedicine. Also, it has short biodegradable time. PBHT AT degrades with the help from soil microorganisms. That was general pros of each biodegradable plastics. Now I'll compare the conventional plastics and biodegradable plastics. Conventional plastics requires more than 500 years to break down under natural conditions. However, biodegradable plastics can be easily decomposed in short period of time if certain conditions are met. Sometimes it is done by microorganisms in the environment. Also, conventional plastics release harmful substances when being degraded. When burnt, it releases toxins such as dioxin, phthalate, and ethylene dichloride. When it decomposes in the ocean, it releases harmful chemicals such as polystyrene-based oligomers and that can cause disruption in hormonal system of animals. However, the biodegradable plastics are degraded into basic components that can be recycled in nature.
So obviously there are certain limitations to this biodegradable plastics as they are not yet fully developed and not been utilized. So according to the study conducted by Imogen Napper from University of Plymouth, biodegradable plastics, or rather fragmented, then broken down into their organic components. What it means is that the plastics they just went from their big chunks to smaller pieces with their characteristics being preserved. So basically that's not degradation but rather fragmentation, and this can cause very serious problems as those fragmented plastics are too small that it is nearly impossible to clean up those plastics, small fragments, once they are released into the environment. Um, Also, most of the biodegradable plastics must be industrially composted, being that if the plastics are in the oceans or landfills, where plastics are most prevalent, they will not decompose very quickly without proper industrial equipments, which significantly reduces the efficiency of those plastics. And biodegradable plastics, especially those robust ones that are often used for coffee cups and food packaging, are expected to act just like traditional plastics in the ocean. And considering that majority of plastic waste are dumped in the ocean, um, the fact that biodegradable plastics will not be that efficient in the ocean will reduce the effectiveness of this plastic. And okay, there are a few more disadvantages of this plastic. So biodegradable plastic can in fact cause pollution and contamination, which is a bit self-contradictory. Biodegradable plastics are made from crops such as soybeans and corns, and there is no way to know if those crops were exposed to any harmful chemicals. So there's a risk of contamination as the crops are typically applied with pesticides and herbicide when they are on the farm. Moreover, some of these plastic products may release some heavy metals during decomposition. The Guardian reported high levels of cobalt and lead in one type of biodegradable plastic, which raised issues about the toxicity left after decomposition. And it is very difficult to distinguish between traditional plastics and biodegradable plastics. And so when those two are mixed, these bioplastics may end up getting contaminated and may not be easily recyclable anymore. And um, when those traditional plastics are misunderstood as biodegradable plastics and are decomposed and exposed to the environment, this will cause even more serious problem as traditional plastics are often much more toxic than biodegradable plastics. And biodegradable plastics can release greenhouse gases. Some of them produce methane when they are decomposed in landfills. The amount of methane produced is very high and is 84 times more dangerous than carbon dioxide as they absorb heat really fast, which can accelerate the rate of climate change as they will absorb those heat in the atmosphere and increase the temperature of the air. And finally, their high cost and high uses of resources. There's a need for costly industrial processors and composters, especially for those that require high industrial scale temperatures to be broken down. And it costs about 20 to 50% more to produce bioplastics than to produce traditional ones. Also, adequate production of these kinds of biodegradable plastics will require the use of land and water to provide the natural organic materials required instead of producing food and actually drinking it. And considering that there are a lot of families in developed and developing countries that who are suffering from food scarcity, um, ethical questions have been arisen about whether this industry is ethically right.
Uh, for application, there are three examples of applications for biodegradable plastic. The first one is disposable plastic. Since biodegradable plastics have the benefit of higher speed of decomposition, it could be used to reduce pollution from disposable plastic. Actually, in Europe, biodegradable plastic is a packing container for groceries. Also in Germany, a company called Danone applied biodegradable plastic for yogurt container cups. The second is composting bag. Since compostable bags emit 8 tons of carbon, composting bags contribute to global warming and the greenhouse effect. There are several applications as composting bags in reality. A company impact manufactured a composting bag consisting of PCR and starch blends called Natureby. It commercialized. Also, a company NatureWorks generated a composting bag with the use of PLA. Or last, it could be applied to medical biodegradable polymer. In the modern day, the usage of biomaterials are completely necessary. For example, if a patient loses some function on several organs or tissues, artificial organs are required. These artificial organs are one example of biomaterials. Anyway, to provide this material, several conditions must be met. Among those conditions, the most important one is biocompatibility. This means how much the biomaterials fit to the original body. At this point, biodegradable plastic is very suitable. This is because it can naturally be degraded with no emission of toxic substances, resulting in less health risk.
So